evening. My name is Scott Kratz. I'm the Vice President for Education here at the museum. And tonight we present a program that explores passive home design as part of our series, For the Greener Good, Conversations That Will Change the World. These tightly sealed and very energy efficient buildings are being constructed across Europe, where 25% of new residences are built to the Passive House standard. In fact, a resolution passed by the European Union's Parliament calls on member states to require that all new buildings meet Passive House criteria beginning in 2012, just next year. Tonight's panelists will examine what American builders and designers can learn from Europe's efforts, where are some of the challenges, and where are some of the opportunities to build more energy-efficient homes here in the United States. We've assembled an impressive panel representing a range of backgrounds and disciplines. I look forward to an in-depth and fascinating discussion. And Richard, this is just a little hot. Could you turn it down just a little bit? Great, thank you. Can everyone here still hear me? There we go, great. One quick program note, for an upcoming event, the museum just opened up registration last week for our Intelligent Cities Forum, which will be on June 6th. In this day-long discussion, White House administration officials, mayors, and experts from across the country will explore how data and information technology are impacting the way our cities look, feel, and function. More information can be found on the museum's website at mbm.org/intelligentcities. And speaking of using data and technology, for the fourth time this season, we are live tweeting tonight under the hashtag FGG. We encourage you to chime in on the conversation and ask a question. For the last three programs, we've had some robust discussion that was happening concurrently. We could not do these programs without the very generous support of our funders, and the For the Greener Good series is presented by the museum's sustainability partner, the Home Depot Foundation, and we would like to thank them for their generous support in this innovative lecture series. And programs such as tonight have been designed where we're going to be breaking periodically for some Q&A from the audience, and it's helpful for our panelists that we've assembled up here to have an idea of who is in the audience. So just by a show of hands, can I see architects that are in the audience? Great. The planners? Great. Landscape architects? Great. One landscape architect in the back. There you go. The engineers? Great. Students? You can raise your hand more than once, of course. Federal or state employees? Great. Educators? Wonderful. That's really helpful, as we know, who we're speaking to. So let me give a quick introduction to our four panelists, and then we'll let them have at it. Katrin Klingenberg is the co-founder of the Passive House Institute, which works in close collaboration with the Passive House Institute in Darmstadt, Germany. She built the first Passive House designed to the German Passive House standard in the US, and designs and consults on numerous Passive House projects across North America. She is the technical director of the Passive House Institute for the United States, responsible for the certification programs for projects, as well as for certified consultants, and is a licensed architect in Germany. Matt Belcher is an experienced builder and developer and a nationally recognized consultant, educator, and author on the business of green building and development. He's been actively involved in the St. Louis area construction industry for 3 decades, including 6 years as a top building codes official. He founded Belcher Homes in 1993, specializing in building energy-efficient, sustainable green homes and light commercial construction, and development management using low-impact, ecologically conscious development practices. He's consulted on large sustainable mixed-use commercial and residential developments, and has commented on the whole building design approach, the philosophy that every decision should be made in the context of what else it may affect in its construction and ecosystem. As an Energy Star partner and EPA Indoor Air Plus partner, he has built homes that provide proven performance through review and testing. He's also a partner in the U.S. Department of Energy's Building America program and its new Builders Challenge program, where homes demonstrate construction that is at least 30% above international energy conservation codes. He also serves on the National Association of Home Builders Board of Directors and NAHB's Energy and Green Building and Building Codes and Standards subcommittees, where he advises on incorporating sustainability into international building and energy conservation codes. Richard King is the director of the Department of Energy's Solar Decathlon, an exciting residential design competition that increases public awareness of renewable energy and energy efficiency. The Solar Decathlon challenges university schools of architecture and engineering to design, build, and operate highly efficient solar-powered houses. He created the Solar Decathlon in 2000 and directed the 2002, 2005, 2007, and 2009 events. He's now working with 20 new university teams preparing for the 2011 event, which will be held from September 23rd to October 2nd. Mark your calendars for those who are in DC. You can follow the action at www.solardecathlon.gov. He's been with the U.S. Department of Energy since 1986, working initially in the Solar Energy Technology Program. From 1997 until 2007, he served as team leader of the photovoltaic R&D program. Recently, he's been working with the DOE Buildings Program to work more closely with professional builders to design and build cost-effective, energy-efficient homes powered by the sun. He holds a physics degree from the American University in Washington, D.C., and on a personal note, in 2008, he built a custom home in Central Virginia that is solar-powered using active and passive design features. The house has been zero energy, for instance, meaning it has produced all its own energy from the sun since the day he moved in. Our moderator this evening will be Robert Ivy, a good friend of the museum, who is the Chief Executive Officer for the American Institute of Architects. He serves 80,000 AIA architects and design professionals through an organization known as the Voice of the Architecture Profession, and whose rich history spans 150 years. In his role, Robert works to increase public understanding of the architect's contribution and the value of design. He helps ensure that AIA members have the necessary tools and resources to successfully address the challenges of the clients and communities they serve. Prior to joining the AIA, Robert was vice president and editorial director of McGraw-Hill Construction and editor-in-chief of Architectural Record, where he also oversaw 16 print and 17 digital publications. With that, please welcome Robert and the rest of the panel.
Okay, good. Yeah, I think I can hear myself back there now. Well, hello, and I was fascinated by this blend of people who are in the audience. It looks as if many of you already know a lot. Maybe we can just sort of fill in the blanks up here with the discussion. A lot of professionals in the audience of different types. The topic is very timely, obviously, and maybe a little bit late, something that we have been engaged in for a long time, literally thousands of years as designers. Houses can be functional and livable and not fully dependent on active systems. And we've known that for a long time. For the recent past, we've been dependent in this country too often on first cost and cheapest systems as opposed to value or high performance. And things need to change. In the beginning of my education as an architect, passive home design was actually passive house design. In the 1970s was another hot topic. And everybody wore Birkenstocks and had a Coulth tube that connected their house and their designs to some I mean, everything was working around these new ideas for passive design, and the publications published, even Popular Mechanics and popular publications, kept us alive with all sorts of ideas. And those ideas are still, some of them are still in currency. But as I said, these ideas actually go back for thousands of years in some cases. For those who are not as familiar with passive design and are here to learn something about it, in a sense, we're basically saying, and I'm grossly simplifying things that we'll come back and talk a little bit more detail about, buildings, houses in particular, discrete, typically smaller, comprehensible projects that are machines for living, as was described in the early part of the 20th century. And there are several basic systems that these machines employ, including the basic tenets of design that I'm sure we'll hit on in some regard, siding, landscaping, building mass, and so forth, but also systems within those buildings and the way that they operate, including the way that they relate to the environment, how they collect sun, for instance, or store it, how they distribute heat or cool, and also how they control or modify those systems. And those are basic, just the most rudimentary sort of things that then flow into the conversation on what makes a passive house. And today it's come to mean something rather specific in that other people have taken this up, and we have some of them here present with us today. So this should be a fascinating conversation. And I'll begin with Katrin because you literally represent a group that has that name in its title. And to your way of thinking, what makes a passive house? How is it different from, say, just a standard production home that we know today, or just a house? What's a passive house in the year 2011?
Okay, so quick sound check. Can you hear me too? Look, is this okay? Okay. What is a passive house in the year 2011? Mm-hmm. So thank you for kind of repeating a little bit the passive housing history. Mm-hmm. And of course, this is nothing new. This has been around for a long time. And therefore, to answer your question, I would rather focus on how is the passive house that we're talking about right now different mm-hmm. from what we were talking about when we were saying passive housing in the 70s. Mm-hmm. And we can talk about the specifics, many of which repeat themselves in what we do today as well, a little later. Yeah. So from that point of view, I would like to start with what is the new thing that we are proposing here that is above and beyond what Passive House was doing in the 70s and 80s. For me, first and foremost, it is the realization that we are in need of an energy metric that we can actually specify and that we can verify, that we can measure to and design to, and that we need to define so that we can meet our environmental requirements, our climate protection goals. How much do we have to reduce our CO2 emissions? Where's this magic spot that we have to hit to assure continuous sustainable living on this planet? That's in my head our biggest design constraint as of right now. And as you mentioned, we might be a little bit too late, but it's not too late, maybe just a little too late to the table, yeah? So if we make a quick decision and turn around on a dime, maybe we can make it work. But of course, that will fail if that proposal will be too expensive. So the second condition is not only to meet our energy metric and our energy goal to meet the environmental goals, but it is also to do that in a cost-effective way so that the cost to society is reasonable. Otherwise, nobody will be able to do it and nobody will be able to implement it. So these are the two pillars of that new passive house movement that has emerged. And I believe that the creation of the software tool around all these elements that flow into passive housing that finally allows the designer to actually assess how well am I doing with my passive design. That has really been a breakthrough. So a good modeling tool that proves to be accurate when measured as well, economic, sense-making suggestions, and our energy metric. Once those come together, I think then we have a packet where we can actually do something with.
Excellent. And two key questions or two key issues that we will return to, and that's metrics and how we measure, mm-hmm. and also cost, which I'm sure people are interested in the way that it affects the way that they live, and what the future holds, because are these going to be cost effective to do? And Matt, you'd be a good one to address this in part, although you don't have to answer it in this first question because you've been involved in construction in the St. Louis area, but also in the area of codes and development for a long time, both as a builder and as a building official. And from your own perspective, how realistic do you think it is to expect more passive home construction in the United States in the foreseeable future, let's say? I mean, how? Why?
Well, I think it's realistic. The technology especially is rapidly finding its way into Obviously, the building codes, they're progressing as rapidly as they ever have with the 2009 edition, forthcoming 2012 edition. And again, the technology all starts with the building envelope. Green is by design and not by gadgetry. So if you do a good job with your design, with the way you put together your building, then you can add your gadgets and minimize their impact. So, but it's a broad picture. Obviously, you need to look at all your resources that you're using to, not only to put into that building, but what it's going to take to operate that building for its future life, and the ability to adapt and bring in new technologies as they progress. But the technologies that are being driven by industries like Passive House Institute just help define those parameters.
And having said that, following up just a little bit with that, with this development work that we see happening, and here you are, a business person who's actually out there in the world engaged with this work, how realistic is that? I mean, are we going to be able to find success, for instance, with the home building industry in achieving some of these challenges? Will others follow suit? I mean, you've certainly joined into this area. So.
Well, it is. I mean, as it becomes more commonplace, obviously it's easier, and in our economy and our way of life, you know, the cost effectiveness has everything to do with it, especially when you get to economies of scale. So the more involved it gets, obviously the more cost effective it becomes. So as the technology gets improved, it's easier to incorporate. I'm doing things now that 5 years ago weren't necessarily affordable in the market I'm in, but frankly, I'm a better builder now than I was then, and it's more cost effective because I can fold it into. The biggest hurdle, I believe, is education. Just turning that big ship around and educating the builders all the way down to consumer, because I not only have to understand the technology, I have to sell it to my customer, and they're the ones that are paying for it. So unless I understand it fully for my own benefit, I can't sell it to them, and that's obviously who's going to really drive the wagon.
Okay,
we can push it, we just need to have it fold too.
So in a sense, you're saying that more begets more. As more people see it, as more people accept it, as more unfolds, others then will join into this. And part of where this gets promulgated is in demonstration projects and in education. You mentioned education. Richard, you've been involved every 2 years with students who are coming from, well, all over the place, literally, here to Washington, and they have found a number of imaginative solutions for houses at the Solar Decathlon. And we are talking in part here tonight about energy efficient solutions. What sorts of things have you seen in your own overview that you think might be instructive for this discussion about passive work?
Yeah, well, certainly there's been an amazing amount of ideas that have come out of these university projects. You know, you just go out there and solicit universities to come up with, using a clean sheet of paper designed from the ground up, a totally carbon-free, zero-energy, solar-powered house, the lowest footprint you can get while you're living in it. When I first came up with the idea in the mid-1990s, the green material movement wasn't real strong. I was working in the solar program and knew we had these way cool, you know, modules that could create electricity or hot water. We made them really reliable, a lot more reliable than the 70s, but the architects didn't know how to use them, and the builders didn't know they were there, and so I just knew there was a real challenge there of trying to teach everybody, not only the students, but the builders, the architects, and the homeowner from that point of view. You need a product, but you also need people demanding it. So the Solar Decathlon has proved to be extremely educational. So they've come up with these wonderful solar-powered houses, and over time they got greener. So from a solar point of view, there's active. You know, you can create electricity from solar cells. You all know pretty much what that is. You got solar calculators. When you put enough of that on the roof, you got electricity. You can also get hot water and space heating just from the heat, the long wavelength radiation of the sun. You can pump that around, circulate that around a collector on your house, you got hot water. So that's what I have always termed, and what I grew up learning was that's active solar. Passive was, all right, let's not buy a collector of any kind, let's just use your house. Take this whole great big box, orient it towards the sun, let the sun come in, but you want to capture it. And so you want some thermal mass of some kind to store that heat from the sun, to let it re-radiate during the night. And you don't want it to be a greenhouse to where you get this spike of going really hot during the day, cold at night, going up. You want to get kind of a sine wave, and that's what the solar mass or the thermal mass does. So that's passive. Lots of forms of passive, from daylighting, let the sunlight come in so that you don't have to have lights on in the house. You can let breezes come through. That's a very passive design. What you're doing is non-mechanical forms to heat and cool and give you comfort in a house. And the students have grabbed all of that, though. The whole building design, the active systems, the passive systems, you know, no carbon when they're living. Now, they're trying really hard to get the carbon out of the building materials, and that's still a challenge. But they have proven, without a shadow of a doubt, over 80 of them so far, these houses, that you can do it. You can have all your modern conveniences just off the power of the sun. They built splendid houses. I don't know if I want to monopolize the time here on this question, but it's just wonderful. Come on out this September and look at 20 new ones who've learned from all the others and are just raising the bar. And so that there's just so many great ideas. And yes, they get ultra efficient because you want to reduce your thermal load no matter whether you're using passive or active. And then they use the solar because you want to watch your ball game at night. You want your refrigerator going. These are very mechanically driven things that you want in your house. And so you do need some form of energy. That's quite impressive.
Well, thinking about the different systems that are employed in passive design, part of what we're talking about here tonight actually is building envelope design, which is critical to understanding what passive house means today. In Europe, it means something rather specific. Could we talk about that a little bit? Let's just talk about how a passive house is made differently from another kind of house. So maybe, Katrin, you could talk a little bit about that, because a passive house is typically hyper-insulated. What does that mean to you? I mean, how does a passive house wall differ? How does a passive house envelope differ?
Well, this is a really good point. There was just an article that came out in the Architectural Record on passive houses, and I thought it was very well written, and for the first time I saw a journalist actually mentioning that the passive solar movement was kind of like not really friends with the super insulation movement in the 70s, and in passive house they seem to have united. And that is really, that adds to, that might be the second edition. How is the new passive house different from the old passive house? There are some interesting things that have come out of this marriage, and that is, for example, one of the things is that in heating-dominated climates, thermal mass is no longer really important or critical. So there have been a couple of really interesting things that have come to the forefront. So it is really about the optimization of all of those things. And it's no longer getting as much passive solar sun into the house as much as you can. It's about the right amount. It's about the optimization of all those elements together, super insulation and passive energies that you can access. And that's essentially, those are the basic principles. You're optimizing the envelope through super insulation based on your climate. That's an interesting question. It's not, so how far do we go with our super insulation? That's in the next question, right? Like, do I insulate this shell beyond control? There was an interesting article by Bill McKibben not too long ago. He said, pile on the insulation so that you can heat your house with a birthday candle. And with that one, he's exceeding the passive house people with their hairdryer by far. So what's our limit? Where do we decide where we stop with our insulation? And the interesting part is it depends on the comfort in the house. what our main criteria for design is we want to create the best comfortable house that we can get to, and that is when we have insulated the wall to a point where the temperature difference between interior wall surfaces and exterior wall surfaces is no greater than 4 degrees F. And that's the magic point, and at that point we can calculate the U value or the R value for any specific climate that we know what the design temperature is. So this is a really cool concept, which kind of puts what we have been building so far kind of like on its head, because so far we've been building buildings that were built the same way, the same envelope north to south, and then we put a giant modulating furnace into it because energy is cheap and energy is limitless. Well, it turns out that might not be
Wrong.
the case. So in that sense, this is a really new proposal. It's a real paradigm shift. We're saying, okay, everybody gets X amount of energy that fits our climate situation, that fits what would be a fair, sustainable energy household. Everybody gets 2,000 watts for those who are familiar with the 2,000 watt society. And then we build our envelope accordingly. What a beautiful concept, right? So, and turns out it actually works. It gives us the most comfortable house. It works off of passive sources. And on top of it, once we do this, our remaining energy is so small that we still need to provide. Now we can afford a PV system. So, and at that point, we are this close to carbon neutrality, and it is here. We have it in our hands, and we just now need the political will to do it.
Excellent. And it still raises questions, though, in my mind about how to gain this sort of critical mass, if you will. Not thermal mass, critical mass, which is different. And Matt, maybe you could talk a little bit about how home builders approach this question, because I would assume that to put in additional insulation, which may be twice or 3 times as much as you would normally apply, requires different building systems, requires an avoidance of transference of heat or cool somehow within the construction of the envelope itself. And does this necessarily cost significantly more or less? I mean, could you talk about just those questions?
Well, that's the $1,000,000 question.
Okay.
Yes, to answer your question, yes, it could cost more or less. And that's the approach. You know, you need, and we're fortunate now, you know, the advances, again, not just with building codes, but with building science too, you know, how we understand buildings work. There's new components for buildings being made all the time, so, you know, we keep building a better mousetrap, if you will. But they all need to be tested, not just theoretically, but in applications. And, you know, besides just the building envelope too, it's as a seller of these commodities, you need your customers' wants and desires. You know, we can build a very tight home. We can build them like an aquarium, literally, and get the equipment size, you know, where it's very appropriate, and really push PV. At a minimum, we try to pre-wire homes for PV, as it's very inexpensive and very easy to do prior to drywall. First of all, it's a great incentive for that homeowner after they get in and realize that those kilowatt hours are actually going to go up in cost at some point in time. Great place to reinvest in their own home. But you still have to balance, you know, what they're going to do. We build the house very tight, make it very energy efficient, and at Christmas time or birthdays, the biggest gift you know, the bulk of the gifts they get all have a cord attached to them that they're going to go plug into the wall. So, you know, the education of those homeowners, why we're trying to do this, you know, is huge, because obviously we build them, they have to operate them. And just the different components that are out there also to be able to study and understand how you tie these together. The homes are truly turning into systems made out of a bunch of different systems, which can make it a very productive, very efficient way to do things, as long as you understand how that works and you tie them all together properly. You know, you do something with the envelope, it can affect your mechanical systems. You improve your windows, it can affect that also. So you just need to understand that balance, the holistic approach, plus the resources it takes to make all that stuff too. You know, it's an industry in our heyday, which I may never see again, at least as long as I'm able to pay attention to it. You know, we're talking about building 1.5 million homes a year. that takes a lot of resources. You know, you talk about sustainability. The sustainability of our industry alone needs to do a good job of managing how we incorporate those parts into what we're building. So, you know, we want to make them efficient. It helps our process to be more efficient, obviously, and make that house more efficient. So the technologies that we can incorporate they're gonna help. It's gonna come full circle.
Are they necessarily harder to build?
You can make them harder to build.
Okay.
Yes. You know, it's a challenge to incorporate. You know, you're trying to really sell a really good building envelope, and you need to put your money here. You need to invest in better windows. And yeah, we can still figure out how to get granite countertops in your budget somehow. And you know, if we just take some square footage out of the plan, we can afford all that stuff. So, you know, it's, again, it really takes a good team effort between the design professional, the builder, all your tradespeople that know what they do. They need to be educated. But you can pull that team together and end up doing a pretty good job for them. And you become your client, your customer's advocate in the process that way too.
I'm interested, Richard, in variation in what you've seen. A passive house depends on where it's located, but I would assume that you're getting examples from all over the world, essentially, and you're seeing examples from everywhere. And latitude matters a great deal here. What do you see in the kinds of variations that you see from different places and peoples? Now, they're all bringing them here to the mall in Washington or to the...
Yeah. So because it's a contest in Washington, they kind of tweak the house for our latitude here and climate and whatever, because they all want to win. I can't imagine why.
Yes, right.
They do, but they all do go back to where they were originated from, to their campuses. So in general, they're kind of designed. Florida houses, you'll notice in this year's competition, they have a white roof. This is Florida International University down near Miami. A white roof, and not so much photovoltaics, because they have such a heating load. They just want to get it off their house, and they have a lot of overhangs. You know, their whole heating load is all air conditioning. They don't have to heat a house in the winter. But you take Alberta, Team Alberta, way up in Canada, they're coming too. They have got the super insulated house. Yeah, they don't get any sun up there. They're just after. No, I'm kidding. But so the sun is lower in the altitude. They just put some windows in a very steep pointed solar array, because you know the sun is lower, and then it's really low in the winter. But they minus 60 below, and so they just want efficiencies that they're not burning so much up there. And it's tough to heat it in the wintertime with the sun so low. So yes, they come from all over. They all work, though, in Washington quite well. The middle of the United States and further south works really good. The farther north you go for a solar-powered house, it gets a little tougher. And you can imagine on the North Pole, it'd be really tough, except right around June, you'd be doing pretty good. So yes, they come, they come all kinds of designs, and that's just the beauty of it, that energy efficiency and certainly solar, for the most part, will work for everybody. Everybody gets it. I'm not knocking wind, but unless you're in Iowa or something like that where there's a lot of wind, you can't do much around here with it. You see no one. There's no rule against it, but you see no one in Washington D.C. on the National Mall with a windmill. Well, there's no wind. Here, you got to go where the resources are. Solar is everywhere.
And that gets a little bit to my next question for Katrin, and that is that often American designers, when they are looking at designs in Northern Europe, for instance, see a somewhat different situation because the climate is somewhat different. And you're achieving certain goals. Here, the additional cost of a house in Germany is slight because of your building tradition or the requirements that are already in place, or a place where there's already a highly developed and regulated system of building. And I'd be interested in your comment on your observations here in the United States as opposed to Germany, for instance, where this passive house movement really took root. What do you think are the lessons and also the takeaways that we could have for the difference between a culture that has really grappled with this already, and for what reasons, and what do you see here?
This is an excellent question. I'm very excited about the opportunities in North America for many different reasons. So you're mentioning maybe the building culture is already more onto it, maybe they're building to a higher standard already in Europe, and it's absolutely true. In Germany, for example, they just recently required triple pane glazing by code, and that of course immediately brings down the cost for the triple pane window itself. But also it makes that additional cost for passive houses much smaller. So at that point, they can decrease the additional percentage that is due to passive house construction. That's definitely true. And it's also true that initially the systems in Europe are more expensive, and that if you eliminate or well get close to eliminating that conventional furnace heating system, that you might get a bigger drop in cost. You get a higher benefit from eliminating that piece of equipment. And yes, it's true that here in the US, the mechanical systems are way cheaper. It's really hard to compete with a $700 gas high efficiency furnace, right? So those were our concerns in the beginning when we started. Like, does that really hold true? Does this magic dip at that point of installation really occur, and does it give us a benefit for the cost effectiveness of passive house? And turns out that it actually does, because initially the building structure itself is not as expensive here, so that's good. And also the opportunities through various different climate zones. As you apply this concept through the 8 different climate zones, way more complex problem in North America than in Central Europe. They don't have to content themselves with humidity. They don't have to content themselves with cooling. So if we consider all these factors in our cost-benefit calculation, it actually turns out pretty okay. And we have developed some really nice cost-benefit calculators by now, and we played around with it for one of the Habitat houses. And Habitat is a perfect example. So if you don't have any down payment or anything, you start at 0. That's how Habitat sells their houses to their inhabitants. They are making money from day one. So we have to start how we think about this additional cost. Is it we should forget about the straight payback right away. We should start talking return on investment. And it's outrageous what you can actually accumulate in terms of money by the end of a 30-year mortgage. I always say, if you didn't build a passive house yesterday, today is your next best opportunity. It's the best investment available on the market right now. If you actually go through the exercise, you look at all, because insulation is cheap. Insulation is incredibly cheap. And then you get that little bit of dip of eliminating the systems. If you figure out how to teach the contractors to build a $400 air barrier instead of a $7,000 air barrier, you're there. And that goes back to what you were saying. Education, 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 bring the cost down. In my opinion, it works out just beautifully.
You mentioned a magic word, though, in your description about Europe, and that was codes, because Europe has, in some cases, some rather highly regulated building practices. And they do matter. As you said, they have direct economic impact. Put something in a code and things change. Matt, you've been a code official. And tell us a little bit about the landscape around, the code landscape around house design and how it might work today for passive house design, or green building codes, if you will, and what do you think needs to happen to it?
Well, first of all, with mandates and things like that, a good example of mandating this kind of theory into codes, we went through this in the 80s after our last energy crisis in late 70s, early 80s, and the Model Energy Code was just introduced in the mid-1980s, and required buildings, both commercial and residential, be built tighter, and that was it. That's pretty much all they did. Well, then we come up with this new phenomenon called sick building syndrome, and respiratory illness in children spiked, and had all kinds of problems. Well, you know, that was then, and we've learned from it. You know, now we have advances in building science and things like that. We still have to pay attention to it. Like I said, we're able to build a building, obviously, very, very tight, but you need to pay attention to what you trap your clients in there with, too. And, but again, understanding, I'm in the St. Louis area, and Champaign-Urbana's not then. We're in climate zone 4, and I always brag it's the hardest place to build in of all, because we heat half the time and we cool half the time. So, you know, simple physics, your warm, wet air is wanting to go through the wall one direction half the year, and it wants to come back in the other half of the year. So knowing it wants to do that, we can manage it. You know, we just mitigate to the point where we can control what little bit might want to transfer, but again, with better building components. As far as part of the problem also with mandating things is the codes kind of tend to drag along behind technology. Mm-hmm. And you can actually make things legally obsolete if you have a better idea and you can't do it. We run into that, especially with land development all the time. We try to go into well-established, self-proclaimed green communities and try to use some pretty good low-impact development techniques. Nothing really new. They've been around for 2 decades, but we're prohibited by their local ordinances from doing this new technology. So sometimes it's better when public officials, you know, when government and industry work together, you usually end up with a better solution anyway. And you're seeing a lot of that now with a lot of the code advancements. The new, the National Green Building Standard came out, and the residential industry is using that. Lead for Homes was developed, and you know, it's been incorporated into the building process, and a lot of those technologies are starting to get incorporated into these homes. Passive house, again, you know, there's nothing you can do to a building that has a bigger effect for less money than just orient it and mm-hmm. then work on the envelope design. So, you know, incorporating those general technologies in the codes is a big advancement, and then leave the minutia, you know, for the industry and really where it needs to be locally applied in those different climate zones. The other issue is enforcement. You know, in Missouri, we don't have a statewide building code. Our large populated areas do. St. Louis County alone has 97 municipalities. Fortunately, about half of them have the same code, and then the rest are scattered. So that creates an issue too with consistency. But in outstate areas, you have no building codes. So, you know, if the mandates get too stringent in the populated areas, well, people drift out where it's cheaper and easier. Well, then you create urban sprawl. So, mm-hmm. you know, you've got a lot of different things you need to pay attention to while you're doing this thing.
And you raise well, something we know but don't necessarily recognize in conversations like this, and that is the interdependency of these systems. Mm-hmm. Sometimes we create a problem at the same time we're solving one. You mentioned the sick building syndrome, for instance. Let's just look at that one area. Let's just look at that one thing and think about it for a minute. How do we make a passive house that has significant insulation? How do we get air in and out? What are the best practices for air movement, for systems, HVAC, for air infiltration or not? What about just basic systems like that? How do these things work to make a passive house today healthy?
Who wants to answer?
Whoever would like to answer that one. Yeah.
Mr. Builder, you're probably better at this than I am. You want to do it?
Well, you know, we pay pretty good attention to the air changes, and I know Passive House, you know, has some pretty dialed down air change rates, mm-hmm. which are fine. You know, it also, you have to pay attention to your occupant load, and basically your consumers' need, what their lifestyle is going to be, that sort of thing too. But you know, again, the technologies that have come along with heat recovery ventilators and energy recovery ventilators, where you can take some of that heat out of that air you're trying to exhaust and bring it back in. Still, they're mechanical systems. So, you know, if we can keep driving that technology to get them where they're working off solar, and you know, make those buildings really perform like we know we can. We just need to keep working on tweaking them.
Richard, have you seen? Excuse me.
Yeah, but you need one whole house air exchange within an hour, right? Is that the rule of thumb? So if you super insulate your house, then the air can't get out, and you start putting ammonia on your floor to wash it, and you've got a health hazard in the making. So you actually want contaminants in your house from washing and cooking and whatever else to get out of your house. So if you super insulate it, you have to mechanically do that. And you can see what the solar decathlon teams do. You can do it with just, you know, a fan and some kind of air circulation. A lot of them like to recover the heat that they're blowing out of the house through a heat exchanger to try to keep capturing that. But the more super insulated the house becomes, you got to think of that, or you got to crack your window at night and, you know, sleep with some air. So that's sort of what you're talking about too.
Sure.
Yeah, and there's mechanical ways to do it. One of the teams over in Europe that built a real passive house just didn't want any mechanical systems in the house at all. Nothing to blow air or do anything. You're just letting the house through natural breezes or through a chimney effect where you let some air out at the very top of a house, you know, like a chimney effect, and then like open a basement window and you get the cool air coming in and the hot air exhausting out. And this was for a Spanish climate where it's always hot and dry, and that works really well doing that. Add a little mist of water and you got your house cool. So there's different ways of doing it.
Are there any new technologies that we've seen that that are either there now or are just on the horizon that might affect something about passive house design, either in air movement, transference, I don't know.
Oh, you know what? Now you're touching on my most favorite topic, and I don't
All
even,
right.
I mean, I might get too much into detail, but maybe you want to bear with me. But I was just at the NASI conference, and Ibicos, a Building America partner, they presented 2 years of measured data of one of our houses that we built a while ago in Fairview in Champaign-Urbana. And we had a lot of people saying, like, this will never work, this is going to be terrible, the indoor air quality is going to be bad, the humidity is going to go up, and it's going to, whatever. So they presented the monitored results, and it was fantastic. We have only one point source, 9,000 BTU heating and cooling unit in a climate with 6,000 heating degree days. We have a heat recovery, energy recovery ventilator, because we're in a humid climate. Helps us in the winter as well as in the summer. In the summer it rejects the humidity to the outside, in the winter it keeps a little bit in. We're humans, we like it at about 50%. The temperature on both floors was within 2F for 80% of the entire time. For heating and cooling it worked equally well, and about like 10% on either side of the 80% it was within 2 and 4F. If you go down only to 20, 40, 60 insulation levels, at that point you're down to 50% with a point source. You're no longer comfortable within 4F of all rooms. So they just presented groundbreaking research results, and we're going to see more and more coming, because a lot of the first passive houses are being monitored and measured right now. Works fantastic. And very critical to that is the highly efficient energy or heat recovery ventilator that has an excellent motor, doesn't need much input in terms of kilowatt hours. And in Europe, they have come up by now with heat recovery cores that recover 99%. They really put their brains to it, like, how can we make sure that we recover all the energy? And that works in summer as in winter, right? If we cool, it keeps the cool air in, and in the winter, it keeps the heat in. So, and then if you want to go beyond that, so we're kind of putting this stuff together with cost-effective components off the shelf right now. But in Europe, they've taken it to a whole other level, and they have built what we call the magic box, because we can't get it here, the compact unit. So somebody a company put their minds to it, and they took all these different components that we need in a passive house. We need hot water, we need solar, that would be great, right? We need ventilation, we need post-heating and cooling of the size of this tiny little hairdryer, 1,000 watts approximately. What else do we need? Ventilation, yeah, that's it. And they put it all into a box, into an appliance that is the size of 2 by 2 by 6, oops, very, very quiet. And the manifolds, everything is prefabbed. So you just plug it in. You don't need a mechanical room anymore. Now imagine you can get rid of the mechanical room in New York City. Ooh, you just made 40 grand. You know? So all these ideas, I think as soon people get to it and they become very inventive, and it's really exciting.
Which makes it doubly exciting if it is being measured, as you described, because what we've lacked are metrics, we've lacked proof. And everyone today is looking for the Holy Grail, and design today is proof, evidence. And so maybe we can come back to that later. Right now, a function of these evenings that's enjoyable is that you can, in the middle of all this, can ask a question or two of the people up here. So who would like to ask a question? There's one at the back, Scott.
I think some of us in the audience would be hungry for some more specifics, and I'd like to direct this at Matt in particular. What are the kinds of things that you find that you're able to sell to your customers and put into the houses that you're building now? That you mentioned the tight envelope, you mentioned some of the other things, and I'd just like to get some notion of what the current market is supporting and where you think we might be going with that.
Thank you for that question. Good question, actually. It's kind of the often asked question. You know, the hardest thing is to convince them that they don't need 3,500 or 4,000 square feet. They can be perfectly comfortable in 2,600 square feet. And man, I can make that house, and if we get it smaller, I can do even more with it. But I can make that house really do something, and it's getting effective. You know, again with the components. Solar, everybody asks about solar. It's still, in our market anyway, it's still, pricey. When we start whittling on their budget, solar usually comes out first. But also, putting that pre-wire kit in, you know, we used to pipe and put a chase in so they could pull future wires for solar. And I talked to the company locally that we did. We just started pre-wiring the homes for solar. It cost $800 or $900 to do it. It was an easy sell to the customer. It's all behind the drywall, and it's a good incentive. And as the technology is developed, the solar arrays they put on the space station are 800 times more efficient than what I can put on a house right now. So you know it's coming. So when they're in their house 5-10 years, they got a little equity built up. What a great place to reinvest it. So, and I think really the cost of the technology with the market going this way has helped bring the cost down of these different types of components, and then just trying to make yourself more efficient in that process. It's a natural reaction as our industry, the home builders, adopted the National Green Building Standard is kind of the go-to document. I've built under a LEED for homes, LEED Platinum homes. And, using that technology and the cost over the last even 5 or 6 years has gotten so much more market competitive. That's what's really starting to make things turn the corner. But, it all starts with a design, with a better building envelope orientation, and then look at your equipment. So if we can get that design down, usually we can do a pretty good job with their budget, with the rest of the stuff, even the granite countertops.
Mm-hmm. And it helps with thermal mass.
Yes, yes. Position them right.
Talk them into the granite countertops.
I'm assuming that the strategies that you've been talking about are all for new homes, but we have a real need for saving energy in existing buildings, of course. And I'm wondering whether you can speak to practical opportunities for applying passive house strategies to existing buildings. And in the solar decathlon, have you had any examples of retrofitting existing houses?
This is an excellent question. Can I? May I?
Mm-hmm.
I had a conversation with Bill Rose not too long ago at the Research Building Council in Champaign-Urbana, one of the leading research architects and has been in passive solar and all. And he's working with the U of I team that is participating in the solar decathlon. And his idea was, man, let's get a track home and do a chainsaw retrofit to passive house standards that's going to win this thing. And of course, the architects had the last word.
Could be a reality TV show.
Yeah.
But it's, yes, so we haven't had the opportunity yet to work on a retrofit. I'm very, very excited about it. I would love to do it. It's a little bit more expensive than new construction, but again, back to your comment, if you think it through, the sequencing, the design, all that stuff, maybe you don't get all the way to passive house standard. The retrofit standard is a little bit relaxed because of that. There are thermal bridges that are in existence and you have to work around. But I think for about like 15–20% additional cost right now, you should be able to do that. And it's a huge market, you're right.
But in the solar decathlon, they're ground up new houses, so we don't have a lot of opportunity to retrofit, except you can learn a lot from them, especially the energy efficient appliances. The lighting you can certainly retrofit in a house. Your windows you can certainly retrofit. Insulation is still the best buy. You know, put more insulation in your attic. It's a no-brainer. It's really cheap, a payback in a couple of years. So there are some good retrofit things to reduce your energy bill. Air infiltration, you hear that all the time by Home Depot or Lowe's telling you on TV to come in and buy something to help you there, and that's a great payback. So.
And don't start with your mechanical system.
Well, actually, if I may comment on that too, one statistic that's interesting is that in terms of architects and designers, 50% of what they touch is pre-existing construction. So think about that. I mean, we think only greenfield, but actually half of what they do has to do with something that's already there. Mm-hmm. We don't often think of that, and I don't know that that's been as, what should I say, that it's a less sexy topic in terms of conversations like this. It doesn't make it to the front page.
Mm-hmm.
Well, 97.5% of all homes were built 20 years ago or more. So, you know, the homes we're building today are 100% more energy efficient than homes built 20 years ago. You know, it's not to say we're just need to do a little bit better. We need to keep improving. But the real energy use is in all those existing homes. Gold star for you for asking that question.
Yes.
But, you know, and frankly, as far, you know, speaking from an industry standpoint, you know, with the National Association of Home Builders, we have tens of thousands of members that are remodelers that are small businesses, good craftsmen that understand this and, you know, understand how these buildings go together. So, you know, it's JOBS too. Jobs is a big thing. So there's preparation and opportunity.
May I add one more thing to this?
Sure.
Very important. Let's all make a pact tonight, political will. Let's not build any more retrofit projects from today. Let's build to the standard that we need to get to, i.e. passive house. Because every building that we are not building to that standard, we're not going to touch them. If we only go halfway, we're not going to go in within the next 15 years, which are critical to our survival potentially. I don't know, I'm just putting that out there. Let's do it right today and don't build any more retrofit projects.
Scott.
Let's see, I wanted to be the spoiler in the room, I'm sorry, but there's a lot of cause for pessimism in this country, and I think it starts with the historic division between home builders and licensed architects that are engaged in all of the other forms of architectural production. One sterling example of this is the book that Libby Owens Ford put out in 1947, the year I was born, and it was, in this book you had a passive house designed by every named architect in the United States at the time. That was one for each state. And a lot of these houses became some of the typical suburban houses of the 60s. You had L-shaped ranch houses and whatnot. But what the builders did was threw the whole passive aspect of orienting the house out the window and then just proceeded to build subdivisions en masse. Another problem in this country is you have production house costs where the builder is looking for a profit. And, you know, there are townhouse developments built here in Washington recently where the dead-on production cost for the for the townhouse unit itself was around $60. The architect is putting out custom houses at around $250 a foot. And, you know, all along, you know, since the home builders are so frequently able to work without architects at all, they are catering to what the home builder wants. And you know, this is a room full of educated people, so we're all trying to take the high road and do what's best. But I still have a fear that in a lot of America, we're still in for a long, tough road. So I would like to hear any comments that you all might be able to bring forth that would make us feel better.
Matt?
Panel. Matt.
Well, first of all, I think that was a pretty good observation. I grew up in a house my dad built in 1960 and used solar orientation, you know, a lot of the building envelope technology, and they weren't his ideas. They were good ideas he probably borrowed along the lines. But, you know, I grew up with the knowledge of how that works with extended overhangs, how they protect the house. I think it's a regional thing as far as the architecture-builder relationship. I know in our part of the country, we don't do anything without architects. You know, I know that there's probably a lot of the areas of the country that's probably true, and I can't really speak well to that. But, you know, builders are kind of going to follow, they're going to do what they can sell. And believe me, I've been all over the country working with home builder associations, talking to builders. You know, it's easier for custom builders, which is primarily what I've done, to pick this technology up, understand it, because every home we do is different. We're used to working with a different budget every time we do something. A production builder, well, they have every last nail in that house priced down to the penny. And it's harder for them. They're a bigger ship to try to turn what they're doing. They're you know, worried about their liability issue, what their salesperson that sits in a display home on a Sunday might sell. You know, they come into the sales meeting on Monday morning and say, look, I sold 2 geothermal systems over the weekend, and they say, oh my God, we have no idea what that costs.
Well,
so,
way, just to interject one thing.
yeah.
I heard the other day from the builder, it was the architect.
Well, it certainly does that, you know. And I gripe enough at my architects, you know. The worst thing that can happen to me is have a potential client come to me, and I'm the first builder they come to with a set of plans from an architect that had, you know, I haven't been able to talk about, you know, the design and the orientation and that sort of thing, because I know I'm going to be priced out of the water. You know, they're going to shop my price, and I'm sure they're going to find somebody that'll build it for less than nothing, and I'm out. So, of course, at that point, I want to be out. But, you know, to speak to the way developments have gone and that sort of thing too, you know, in speaking with those builders around the country, not so much today as it was 5 or 6 years ago, back, you know, in the heyday, you know, the biggest 4-letter word in the industry was change, and it kind of still is. But the biggest thing was, you know, why do anything different? We can't keep up with what we're doing now. And, you know, it was being pulled that direction too, and I think it goes back to that education process. Now we're looking at the builders that are using these technologies. There's fewer buyers in the market, but they're more discriminating because they can be, frankly. And I know in our neck of the woods, the guys that are building green using these parameters all seem to be kind of busy right now in a rather dead time, and that's really turning some heads in the industry. So.
Yeah, I think any good architecture firm today, if it's going to be in business, has to design green and have energy efficiency in their mix. I mean, I think I have a more positive viewpoint than you do. I think things are really turning around. Yes, we need to rebuild the 20th century and that huge stock of buildings that we have out there. But everything that's newly being built from the architecture community, I think, is a vast improvement and getting better all the time. Yes, there are still some houses in a tract near me outside of Washington here that are just square boxes, but that's the cheapest way to build housing, and there's a lot of people who can't barely afford $150,000 for a house. So a square box with 6 windows and a door is the cheapest way to do that for them. And I don't know how to get around that except for the Department of Energy has stricter and stricter codes. I know NAHB does, and AIA keeps working towards that. And the only thing we can do is force you, the builders, to keep raising the bar, keep raising the codes to get more and more energy efficiency.
Well, I think if, instead of forcing us, if you promote what we're doing, help us.
I don't mean force it,
Thank you.
from that point of view.
Yeah.
No, well, let me throw one other big factor in the equation here. You know, I can build a house and really make it cost competitive, you know, dealing with my competition that's maybe doing a lesser job, at least in my eyes, than I am. However, the appraiser comes in and they can't close their mortgage until the appraiser gives me the numbers. And, you know, he's appraising my house either on the same level or even maybe below because he doesn't understand what I'm doing. Mm-hmm. And, I mean, that's a huge blow. We've had houses appraised from the construction loan. They'll appraise till the guy comes through and does his walkthrough before they close the mortgage. Nothing's changed on the plans or anything. House was built to spec and to plan and to budget. Mm-hmm. Knock on wood. $100,000 difference in the appraisal. Mm-hmm. I mean, how do you do that? You know, and as a business person, it doesn't work. Now in Missouri, we're working with our local appraisers on statewide. We're trying to modify that rule. You know, being from a little bit of an agricultural background, if I was to sell a farm, an appraiser has to come and do that appraisal that is qualified to appraise agricultural property. So we're trying to tweak that appraisal rule that they have to, now that the Appraisers Institute, NHB has worked pretty hard with some of the appraiser organizations to try to get education out there. Well, now we're trying to tweak that rule. If they come and do an appraisal on a certified passive house, Energy Star, Builders Challenge House, National Association of Home Builders Green Building Program, if it's certified, they have to have some kind of education. At least you have a chance that that guy knows what the heck he's looking at and why.
And that raises the issue of evaluation, certification, and some sort of acknowledgement that of the value of these houses. And then also the question of how they are evaluated. And I'm interested in how passive house certification works. What sort of evaluation is really suggested or used? Is there a methodology in place? Is it different in Europe from the way that it is operating here? What would be the best system? Katrin, you might talk a little bit about.
Well, in general, we're following the same certification protocol that the Europeans use and the essentially worldwide certifiers use. It's a building science principle. It's we're checking various principles. Yes. That said, there is a specificity to a specific market, of course. There always needs to be an adaptation. And what that certification protocol does that has been specified by the PHIs is verifying the design and the optimization. So they are very focused on their design tool, which is great. Yeah, because we never thought about that we actually should verify that the design was done right and well done and optimized. So now the next thing is, since it's a simple idea, but it's not that easy, how do we get these things on the ground and they don't fall apart? First, that happened in the 70s. A couple of people forgot the ventilator and the houses melted away and the whole thing got a black eye. Can't really afford that. So we need to make sure that the quality assurance is there and put in place and that there's a system there and that can actually assure that. And it takes specialty knowledge to do quality assurance on site, make sure that the insulation is in correctly, thermal imaging to maybe a higher level than what we are used to typically, blower door testing at different stages for diagnostic purposes.
And who is doing that? I mean, who?
Well, and I'm trying to get to that. Yeah. That this led us to forming an MOU with ResNet, because there's a world of qualified professionals out there that have great experience, and with a little bit of more education, we lift them up. Maybe we require a thermal imaging class next level up. And those folks can do at a very cost-effective level, make sure that that quality is accurate, and they can then also print out the verification, and then homes would qualify for tax credits. So that's the grand scheme and plan, and I think this is all working out quite well.
Okay. How about government involvement here? Obviously, you're giving a sort of through certification, you're giving us a stamp of acknowledgement of what these things are achieving. Programs like our educational program, obviously, are raising awareness. But what about actual government programs that are in place now? The tax credits, the possibility of some other forms of encouragement by either state and local or federal authorities?
There's great incentives out there for energy efficiency, for renewables, and like wind and solar. How many of you know the website desireusa.org? Mm-hmm. Most of you know that. Database of state incentives for renewable energy, and you put a USA on the end of it. Don't put desire in it. Your Google, you'll be. So it's DSIRE. And USA on the end of it. So you can click on every state, you can click on federal. If you click on federal at the top, it'll give you all the federal incentives. I got a 30% tax credit on my solar system 2 years ago. It was wonderful. And there's others for efficiency. They're running out though. And then you click on your state. If I went to Virginia, I'd see state of Virginia. I'd also go right down to my local utility. Maybe my county has an incentive. It's wonderful. We pay, I think it's the North Carolina University to put that together, keep it up to date. It's almost put up to date daily. So go there for incentives. There's lots of stuff out there to just help you. If you want to retrofit your house, keep those receipts from Home Depot, because they'll, you can get tax credit on that.
Actually in Massachusetts, they have a really great deep energy retrofit program right now. Anybody here from Massachusetts? They have 30,000 for deep energy retrofit, and you get 10,000 in addition if you go to passive house standards. So they are really leading the way with some pretty great programs.
What about lessons that could be carried forward, not only about passive house, but direct applications in other forms of construction or design, say for commercial, institutional construction? Are these things that we've been looking at specific to house design of a certain square footage, of a certain footprint, of a certain type? Can these things be...
well, it gets better. The bigger, the better.
Okay.
That's the great thing. And actually, the passive house in the U.S. and the English-speaking world is a little bit of a misnomer. And it's a funny story, actually. When Dr. Feist first started researching passive housing, what he did was he bought up all the books that were written in the U.S. by William Shercliffe and looked at Harold Orr's Saskatchewan house in Canada, and what else was there? Ned Nissen Super Insulated Home Book. And passive housing was a household name, and people used that as a scientific term, and they translated it into German. So this is how we end up with this thing. So really, it should be called passive buildings, passive energy design, or whatever. It's obviously it applies to all types of buildings.
Okay. Out of what we have heard tonight, and we're going to give the audience another chance to ask questions here briefly, but what, in terms of sort of quick summary, do you think you wish that they would carry forward from what they have heard you say? What lessons do you think are critical for us out of our discussion tonight?
Energy efficiency pays off, and solar really works. You just write that baby down.
Right.
Energy efficiency pays off, and solar works. It's you want to reduce the energy load in your house because you don't want to be spending a lot, and you're going to be spending a lot more as time goes on for energy. So you want to reduce that load, and then you want to use the free energy. There's so much free energy out there just right outside your window that you want to kind of use that. At least that's in my book, and you got a win-win solution there. I'm also into, if I got a minute, can I monopolize?
Go for it.
I'm a solar guy, but I'm also into simplicity and longevity and low maintenance. So my house that I live in, and it's zero energy, I've been a little surplus with only 6 kilowatts photovoltaics, because I am using passive, no maintenance. I just, you know, the passive part, when you're talking solar passive, is I took the north, all the north but a few, most of the north windows, and put them on the south of my house, because I have it, you know, I had the option of, here's my piece of land, there's south, let's point the house right towards south. And we're in a climate zone where the heating load is the higher load, although air conditioning's, you know, still a load. So I wanted the sun to come in. I've got a lot of south-facing windows. I put a nice stone wall in my great room, which I call thermal mass. And then I have overhangs about 3 feet out on the south side, although to make it look nice, it's symmetrical on the back too. So that when the sun is up in the summer and you don't want that heat, it's actually being shaded. No sun comes in my house. There's very little now coming in my house, even at this time of year. So that's no maintenance. That's part of the shell of the house that's going to hopefully last 100 years. All I did was move windows around, and I'm probably getting a $500 payback every year for nothing. All I did was move windows. I have a thermal mass wall, and I have overhangs. I'm not getting up and even working a thermostat. It's just working for me all year round. No maintenance. You know, I put foam insulation in because you don't want air infiltration. And I put great windows in. The best at the time were Marvin German windows. They're really good, thermal pane. They're not triple pane, but. And then a 6 kilowatt PV system in the house. And basically, it's, other than that, it's a pretty stock house. I'm a government bureaucrat, believe it or not. We don't have a lot of money. So it's just a good old 2,500 square foot house. And I haven't paid a utility bill because it's all electric. I'm into this no carbon thing. So with photovoltaics and passive, I'm creating no carbon on my house. I'd like to address the 2 cars in my driveway, but at least living there, I'm not creating any part. So it's an all-electric house too, and I could get into more. So that with just the photovoltaics, the inverter's just working great. It just runs my meter backwards, and so the utility comes out every month and says, "Oh, you produced more than you used." Well, you don't get a bill. And I just started selling renewable energy credits. I'm making $200 a month off of selling credits up to Delaware or Pennsylvania or somebody who wants that, so it's pretty cool. So there's a good message for you. Energy efficiency pays off, and solar really works. It does. Come to the Solar Decathlon this September. You'll see 20 new designs, and this year we put an affordability contest in. They have to be $250K or less in order to win, so they're much more affordable. They aren't going to be plastered with photovoltaics. We proved that point. It'll be quite an interesting competition.
That's actually an excellent summary, and part of what you say is what we began with, is that it isn't nuclear physics. In fact, some of these the technological really questions that we've described are not that complex. The more complex questions here that I've heard tonight have to do with human systems. They have to do with education. They have to do with markets. They have to do with certification or acknowledgement, and let's say adaptation and adoption, and with developing metrics. And these are human systems, not necessarily technological ones. We need the technology, the basic technologies, to make the systems work, but it isn't as if we have to go out and invent something. It's that we have to promulgate ideas that are already present. Who else has a question in the audience? We have time for 1 or 2.
Uh-huh.
I think this is just a practical question, but I'm intrigued. I'm intrigued with how one gets thermal mass in a highly insulated envelope.
How do you get thermal mass in a highly insulated envelope? Well, I built a stone wall because I like stone. I didn't want to put a fireplace in. I just built a good old. It's 9 feet high and about from here to there, just on one wall. It would be you know, if this is the south and the windows are coming in, the sunlight hits the floor, except when it's really low on a west window, it actually hits my stone wall. So you can just build stone, you can do it with water, you can do it with masonry. Those are your two best, least expensive ways to do it. And then your house, you know, tile floors, your house has a lot of embodied thermal mass in it also. It just stays either warm. It's just great to come out, you know, bedroom in the morning and my house is still 65 degrees on a winter day, and vice versa when it's cool. You can it just re-radiates. Does that help you?
This is actually from multifamily, and I had a thought about doubling up sheetrock on certain walls.
Just use type X. Type X, twice as heavy as regular drywall.
Mm-hmm.
I think
Yeah.
we've.
No, I was just gonna. You have any other idea? I mean,
Well,
I'm
yeah, I would add to that if you go to passive house levels, at that point the thermal mass becomes highly climate dependent. There are areas where you can have too much thermal mass. So for heating dominated climates, they found that actually the mixed construction performs the best. It's not the lightweight construction, it's not the heavyweight construction, it's the one that has thermal mass all over the building distributed, and not only like in an area where it's being hit by the sun, but it's rather a reflective process as well. Of course, in the cooling climates,
scatters.
absolutely at that point, oof, yeah, you want that stuff big time, yeah.
I just want to ask about measurements. When I go buy a car, I look at the miles per gallon and what it's cost me, and I can do a quick, simple payback over. Are you sharing? Do you have that kind of information you can share with? I was asking about measurement. If we're going to have information that we can share.
Yeah, the question was just about measurement, and you know, really, this is kind of an outfall of building with the Builder's Challenge program. You know, when you build a house with an envelope as tight as we make it, you know, if you're building the Energy Star, one of those programs, you need to rate that house anyway. But I think even if you're building the No program, if you're just trying to build a tighter envelope and make your performance better, you need to somehow test that building to see where you're at. You need that baseline data. You know, there's no way you're gonna, you know, trim out your system to make it work properly if you don't, especially with the load of occupants that you're gonna have in that house or building. But through the Builder's Challenge program, they started metering that house, and I actually get data back from DOE. I get a label that goes right on my customer's panel, and obviously we get the theoretical data in front. We take our designs, same way with passive house. We take our designs, we have a theoretical goal that we're going to hit, and obviously we want to prove that out. So it does kind of give us that miles per gallon sticker, if you were. That's now going to be part of DOE's plan, you know, with the existing homes. That's going to become more mainstream, but that's a good example of where some of these programs like Builder's Challenge, Passive, you know, some of these advanced programs, you know, kind of pull things along and they become mainstream.
I'd like to add something to that. That has been and is still a little bit of a challenge because where's our benchmark, right? This whole percentage thing, like 10% better, 15% better, then the house doesn't perform anywhere close. And that's kind of like the trap that the lead buildings ran into, even though we had energy performance modeling and the monitor data didn't really match with what actually was happening. And we're just, as far as I know, the PHPP is the closest and verified modeling tool out there that actually gives you a reliable miles per gallon output prediction. That still does mean that it's going to be right on. You could use less, you could use more, but that's exactly what this modeling tool aims at. And it's much better and proven than the other modeling tools. And I'm not saying that this is my scientific opinion about that tool, and this is what attracted me to Passive House to begin with. And we're actually starting to work with other organizations who are aiming at producing a consumer label that will actually have that that miles per gallon on it, and they are looking to us because they know that this modeling tool is very, very accurate.
Just real quick too, one thing, it'll make it easier to sell this technology, first of all, just like you were trying to get to, if you have something established. You know, on the other side, the selling end, you know, and this is a big concern, especially on the production side with builders, the liability that they perceive would be out there saying, you know, I'm saying this house is 50% above code or whatever. We're putting a sticker on it saying it's going to perform to this level, and then it doesn't. You know, they don't want to end up getting sued over that sort of thing. So, you know, again, with the better building science, the testing criteria that's out there, the quantitative data, you know, organizations like RESNA, exactly, that narrow that in. And frankly, I like all those different third-party testing because that removes a level of liability off of me too. So,
I think we have time for just a couple more questions and then some final thoughts.
Okay. Katrin, I would like to know what is your opinion on the role of the architects on successful PH projects, and how do you think that is the best way, or on your experience, to implement that?
Well, that can potentially be a long-winded one or a very short one. I think the architect is the central person in the team playing effort. I'm an architect myself. This is why I was attracted to the profession, that you really are able to be proficient in many different roles. And PH makes it actually much easier for the architect to do all these things, because now the mechanical system has been minimized. So you can actually start to design and lay it out yourself. You might still want to have a contractor, HVAC person who is helping you out with it, but you can actually manage it yourself. So if you go to passive house standards, the architect is essentially able to control almost all facets, and that design piece is so important. But then that said, that all ties into the implementation and talking to the builder right up front from the beginning, and making sure that that dialogue is kept to make it most cost effective. So there are lots of challenges for the architects compared to how they are working right now. They have to come up to speed in many ways. They have to come up to speed in building science. They have to come up to speed in cost assessment, mechanical engineering, all that. So hopefully we're coming back to that master builder, architect, design build is really the way to go. If you can couple up with a builder, I mean, at that point, that's the winning ticket.
yeah, I work with my architects because I'm in the market every day. So, you know, I know what building materials cost, you know, lumber, plumbing, et cetera. So, and I pull those guys into the conversation. We sit down at the architect's conference room table, and we virtually build that project right there at his table. So by the time we get to the field, we've all built it one time. You know, we don't have the issues where the plumber and the HVAC guy are standing there arguing over which joist space they're going to run their materials at $50 an hour. And we've already solved that problem. So.
Okay, one last question, and then we'll have some final thoughts.
Hi, I'm an architect, and I am trained in passive house. One of the things I've been looking at lately with some disappointment is all the lists of things you can do to get energy credits with the government. I don't see energy recovery ventilators on those lists, and I don't see hot water energy heat recovery pipes on those lists. And it seems to me the first thing that someone should do if they're going to retrofit a house or design a new energy efficient house is think about putting in the energy recovery ventilator. I'm a big fan of ventilation, and I hate stuffy buildings. I mean, even if you put a meter in here, we're probably getting high on CO2. Mm-hmm. What happens in commercial buildings is the owners turn off the ventilators because it costs money to heat or cool the required ventilation
why
area.
It's so hot in here?
And if they were required to put energy recovery ventilators in, equipment in, then there wouldn't be a cash incentive to turn it off, because it doesn't cost you anything to run it hardly. It only costs you to buy it. But you go to do and if you're going to do a renovation on a building, I think the first thing you should do is put in the energy recovery ventilation system so you have healthy indoor air, and then do your blower door test and tighten up the house, and then you can make it really tight. Because right now the people doing the blower door test will say, well, don't make it too tight because then you're going to have an indoor air quality problem. So I think there needs to be a huge promotion of energy recovery ventilators and hot water heat recovery pipes. Mm-hmm. And it needs to get into every single list, you know, that you can get energy tax credits for or savings. And, you know, go to your website for DOE and look at your ideal house. There's no energy recovery ventilator in your diagram. So are you planning on doing anything either in the codes or in your promotional programs to encourage energy recovery ventilators?
Good question. I'm afraid I can't answer that because I'm not in the code group, but I'm certainly happy to carry that back. I would think that if I were to put one in my house when it comes time to replace my heating and cooling system, that it would be part of the package, and if there's a tax credit for that, that whole cost of that package, including the piping and the labor, would be have the tax credit. But other than that, I can't answer it.
Actually, it works very well as a standalone system.
Just
to come in and put it in your house now.
Yeah.
Oh, they're great. And as far as residential especially goes, you know, not too many years ago, I'd have to put a commercial type unit in, but now they're manufactured for residential applications, and they're wonderful. Now, you know, I do a lot of geothermal installations with my construction, and we put them in there, but they fall under the 30% tax credit because that credit applies to all the equipment that goes in there, including that ventilator. My HVAC contractors put it right in with them. So, and yeah, I mean, that is one little piece of equipment that makes a huge difference. You know, otherwise you're just exhausting all that paid-for air, if you will, all that energy.
For all those passive houseless here in the room, actually earth tubes and closed ground loops, passive ones, are geothermal systems, and you get 30% tax credit.
So, we've had an hour and a half discussing the passive house. I don't know that we solved problems. Maybe just as one last question I might ask, what sort of developmentally do you think is happening with passive design, and what should happen? Should we see advances in government? Should we see, I don't know.
I think there's a lot of advances out there, and I think with different standards too. There's a standard also in Europe called Active House, which I don't know if they're a competitor with Passive House or not, but yeah. But you know, they're again focused on a lot of the same things that the National Green Building Standard is for residential and LEED for homes. But with all those different standards out there, there's a lot that need to come together, obviously. But also, you know, there are little specialties that they have, just like Passive House. The building envelope is so important. That's where you begin with. So to be able to have that program to drive that technology is hugely important, and I think the market is, at this point, is really helping all those things.
Mm-hmm.
Well, I think you're hitting on something there with the Active House. So just to clarify, Passive House is not a brand. Active House is a brand. How is Passive House different? Passive House is an energy standard. Mm-hmm. And an Active House, at least in Europe, it is also a Passive House because it has chosen that as its baseline. So beyond Passive House, we were talking about that earlier, if you only go the passive route, Passive House standards, that we're talking the energy metric, yeah, right? The factor 10 reduction, that's a must. We got to start there. And then after that, we can concern ourselves with our design constraints of carbon neutrality. Yes, we want a renewable system. We want to overproduce. We want to make up for all these other guys who are not caring or whatever. So that's what Active House is shooting for. They're going to set standards that take Passive House as the baseline and then add various levels of renewable and energy production.
Yeah, I saw in a local newspaper just the other day, they had a big article talking about all the different power generation, you know, coal-fired plants, nuclear, so on. Not one mention about how about energy conservation. Let's start with that. We don't need all this other stuff. So not one word about it, though.
Scott, I think we've not exhausted the topic, but we've begun the topic. So it's.
Sorry about that. You'll have to invite us back.
Yeah. Thanks to the panel. Thanks to all of you for coming out tonight.